All right, so 10.7 is going to talk about complex numbers. So this is what happens when you get those negatives in your even radicals. And here's what we do. So mathematicians don't like when they can't get an answer, so they made up an imaginary number. They said, we're going to call this number I, and it's going to be equal to the square root of -1. When you square both sides, you get I squared equals -1. So that is the definition of I. Complex numbers have real and imaginary parts. That's what makes them complex. The real part for this one is -3. The imaginary part is the part with the I, imaginary. So 5 could be written as 5 plus 0i. So 5 is real, 0i is imaginary. And then over here, we could also say 0 minus 3i. So 0 are real, -3i is our imaginary. All right, if we were to make a flow chart. So complex numbers are written a plus bi. You have your real part, and you have your imaginary part. Real numbers could be a plus bi, but b always equals 0. Rational is anything that can be written as a fraction. Irrational is anything that can't. So like pi or the square root of 3. Non-real complex is when you have something on the I. You could have a number with A, you could have a number with B, B is not 0. Pure imaginary is like this -3i up here where A equals 0. All you have is the imaginary part. The way we use this is square root of 9 or -9. We can rewrite that like -1 times 9. The square root of -1 is I by that definition. So it brings the I outside like this. And then the square root of 9 is 3. So we get 3i. That's how that works. So here, square root of -25. Well, square root of 25 is 5. The negative sign gives us an I. Square root of -7. The negative we're going to take out with an I. 7 doesn't have an even square root, so unless it tells you to round, leave it just like that. Number 20, we can simplify. So I can rewrite this as like -1 times 4 times 5. The -1 becomes an I. The square root of 4 is 2. Leave the 5 on the inside. That's how you simplify radicals with i's. Now, when you're adding, subtracting, and multiplying, you treat I like any other variable. You just combine like terms. So we would combine -3 plus 2 is -1. 2i plus -i is 1i. There's our solution. Subtracting, same thing. 6 minus 2 is 4. And -3i minus 5i is -8i. There's our complex number. Multiplying, we're going to FOIL. So first times first, outside times outside, inside times inside, last times last. 2 i's make I squared. Now the big difference here is I squared equals -1. So -12 squared is the same as saying -12 times -1, and a negative times a negative turns positive. So this I squared is just going to change the sign. Then we can combine like terms. So 2 plus 12 is 14, and 8i minus 3i is 5i. You try these three over here, see how you do. All right, -7 plus 3 is -4. 2i plus -4i is -2i. 3i minus -i is plus, so it'd be 4i. And then we have -5. So we could have written it like that. A plus bi form, which is what MyLab wants, is always going to want the real number first. Just so if it's marked wrong for this in MyLab, that's why. You don't have to change it. I'll fix it. All right, here we have 5 times 5. 5 times 2i. -2i times 5. -2i times -2i. That I squared is going to change the sign. 25 plus 4 is 29. 10i minus 10i cancels. Maybe you noticed this from before when we were doing our conjugates, but these are the same. The only difference is the plus and the minus. So it's called the complex conjugate. We'll get into that in a minute. All right, reducing radicals. They're always going to follow a pattern. So anything to the 0 power is 1, always. Anything to the first power is itself, so I to the first is I. And then I squared is -1 by definition. Now, I cubed is like saying I times I times I. Well, those two i's mean I squared. -1 times I is -I. And that pattern's going to keep going on and on forever. I to the 4th, I to the 5th, I to the 6th, I to the 7th, and then it's going to reset. So this pattern will always be true. So you can simplify any power of I by dividing by 4 and figuring out which of these it is. So 0 is like 0/4 or no decimal. 1 would be like 1/4 or 0.25. 2 is 2/4 or 0.5. And 3 is 3/4 or 0.75. I'll show you what I mean. Take this exponent, 9. 9 divided by 4 is 2.25. The decimal is 0.25, which is this one here. So I to the 9th is going to equal the same as I to the 1st, which is I. 19 divided by 4 is 4.75. 0.75 is 3/4. So I to the 19th is the same as I cubed, which is -I. 40, same thing. 40 divided by 4 is 10. There's no decimal, so we say it's the same as I to the 0, which is 1. So no matter what power of I you're given, it's always going to equal one of these 4 things. All right, complex conjugate. You only change the sign of the imaginary part. So if you have a 5 plus 3i, the conjugate is 5 minus 3i. -2 minus I, the conjugate is -2 plus I. -4i, so we just change it to +4i. -6, there is no imaginary part, so we just leave it at -6. You use that complex conjugate to divide. So just like we were doing earlier with the square roots and rationalizing the denominator, we have to get the imaginary part off. To do that, we use our conjugate. So this is 3 minus I. The conjugate is 3 plus I. So we put that on the top and the bottom, and then we FOIL. 2 times 3 is 6. 2i times I is 2i. 3i times 3 is 9i. 3i times I is 3i squared. Do the same thing on the bottom. 3 times 3 is 9. 3 times I is 3i. -I times 3 is -3i. And -I times I is -I squared. The I squareds are going to change the sign. So -I squared is really like saying +1. Combine like terms on the top. 6 minus 3 is 3. 2i plus 9i is 11i. On the bottom, 9 plus 1 is 10. And 3i minus 3i is 0. So here is our solution. When they want it in a plus bi form, you just break it into the real part and the imaginary part, which has the same denominator. All right, let's check this one out. All we have is the 2i. So the conjugate would be -2i. So 4 times -2 is -8i. And 2i times -2i is -4i squared. So -8i or -4i squared. That I squared is going to change the sign. And then -8 divided by 4 is -2. So we're just left with -2i. All right, last one. We're going to turn this into 3 plus 5i. I don't understand. I'll get here. Okay. 3 plus 5i. So 4 times 3 is 12. 4 times 5i is 20i. 2i times 3 is 6i. 2i times 5i is 10i squared. 3 times 3 is 9. We know the rest is going to cancel, so we could just automatically skip that step. The squareds change the sign. 12 plus negative 10 is 2. 20 plus 6 is 26. And 9 plus 25 is 34. All of those numbers are divisible by 2. So we could rewrite it as 1 plus 13 over 17. I will accept that on a test. And then my lab's going to want the A plus BI form. So you would turn it into this. That is 10.7. Let me know if you have any questions.